company Aquifer, which was founded in San Luis Obispo, strives to bring clean water to rural areas around the world. Aquifer desired a new and improved cable drill rig based on the existing Borelite model. The newly designed Borelite drill will be mass-produced and sent to underdeveloped countries. The Borelite upper team was tasked with designing and assembling the drilling mast and head. All three teams had an overall budget of $30,000. We would like to give special recognition to our sponsor Matthew Talbert, as well as our advisors Dr. Bates, Dr. Haberlin, and Mr. Forbes.
A complete set of plans was developed for mass production of the Borelite drill. When disassembled, no section of the mast exceeds 13 feet. This is a model of the mast being folded, raised, and lowered.
Fabrication began with the derrick, which consisted of 3 sections of 6x6 1/4-inch steel tubing, each measuring 9 feet long. 6 half-inch steel plates were added to the ends of each section of the derrick.
Two 2-inch hinges were fabricated for the upper section. The first hinge is the pivot point for the derrick. The second hinge is used for folding the head for transportation.
The head consists of a pulley system that was repurposed from the original Borelite drill. The cable wire rope snakes through the frame and through the pulley to the drill stem assembly. The pulley is attached to blocks that slide and compress a set of springs during the drilling process. This reduces the load from the drill bit on the head and pulley.
Here, the derrick is being attached to the middle section of the Borelite drill. Here, the head is being attached to the derrick to test the hinge point at the middle of the mast. A support was added so that the derrick is secured during transportation.
Once the rig was completed, it was disassembled and painted to the original Borelite color. After the drill was completed, the acceptance test was performed. The following are the criteria for the acceptance test. Swing the derrick and head out so that the mast is completely horizontal and suspended. Once everything is considered safe, bolt the half-inch steel plates together to fully connect all pieces of the derrick. Raise the mast by testing the hydraulic cylinders. The new hydraulic cylinders should take longer to raise the mast than the original cylinders. This will create more stability. Once everything is considered safe, continue raising the hydraulic cylinders so that the derrick is at a 90-degree angle. Raise and lower the stem until a borehole begins to appear. this process until there is a borehole 3.5 inches in size and at least 4 inches deep. Switch the stem for the baler by running the cable wire attached to the baler through the smaller of the two pulleys and continue the up and down motion to extract the excess soil. Lower the hydraulic cylinders so that the mast is parallel with the rig. Unbolt the half-inch plates and swing the mast back into its resting position. The test was performed and satisfied all of the acceptance criteria and drilled a rate faster than 4 inches per hour.